Calculating percent yield is actually not difficult at all. It's just a matter of understanding what you're being asked for. So let's jump right into a problem, and you want to copy the problem in your notes and then work it out as I work it out. So 9.87 grams of ammonia reacts with excess carbon dioxide to produce 13.74 grams of urea, and that gives you the formula there for urea. What is the percent yield for this reaction? And first of all, we can see that we've already got coefficients in the equation, so it's probably balanced, and if you double check, yeah, it's balanced already. So what we have to do here is understand that the wording tells us that we don't have to worry about a limiting and excess reactant, even though, yes, we do have two different reactants given to us, or in the balanced equation. We have this ammonia and we have carbon dioxide. The problem is telling us the exact amount of ammonia, and it's telling us that it's reacting with excess carbon dioxide. Therefore, we know that our limiting must be the 9.87 grams of ammonia, because it's telling us that the other reactant is excess. So we don't have to worry about CO2. So what we're going to do is simply determine how much product, in this case we're talking about this product, the urea, should be produced by reacting 9.87 grams of ammonia. Because as you guys found out, in the lab already, you don't always get what you're supposed to get in terms of the amount. So let's go ahead and start by converting the 9.87 grams of ammonia to grams of the product, urea, that we expect to produce. Because it may turn out that we were supposed to make 15 grams or 20 grams, but we only made 13.74. Whenever you're given a number in the problem, an amount of a product, we refer to that amount that we're given, in this case 13.74 grams of urea. This is called the actual yield. In other words, it's how much you actually made. So let's figure out the theoretical yield, which is the amount that we should have made. So we're going to do that by starting with 9.87 grams of NH3, and we're simply going to convert that to grams of this CN2OH4, the urea. So go ahead and give that a shot on your own. Okay, so there you can see that I calculated 17.397 grams of urea should be produced from 9.87 grams of NH3. That's not how much I did produce, though. The amount that I should produce, which is sort of like the calculated amount, is referred to as the theoretical yield. So in theory, if everything goes perfectly and my reactants are pure and I don't drop anything or mismeasure anything, that's how much I should get. The last step here, it's asking what the percent yield is. Percent yield is simply actual yield divided by the theoretical yield times 100. So our actual yield in this case is 13.74 grams. And our theoretical is the one we just calculated. So 17.397 grams. And I'm just going to go ahead and leave extra sig figs on there because this isn't my final answer yet. And so when I divide that, I get 78.98%. Looks like going all the way back to my original problem, I'm limited to 3 significant figures by the number 9.87. So 79.0 would be my percent yield. So I made 79% of what I was supposed to. Okay. So this is an example of a problem where you are essentially given which one is limiting because you're only given information about one reactant. So how would we handle a problem where we were given information about both reactants? Now, first of all, we should balance the equation. This one's not balanced. It looks like this P4 which, by the way, don't worry about that. It is possible for phosphorus to have a subscript of 4, even though it's an elemental form. It's not a Brinkelhoff or anything like that, but it can exist as molecules of P4. Regardless, I have 4 of them on the left, so I should have 4 on the right, and that gives me 12 chlorines on the right, so I need a 6 there on the left. Okay, so anytime you're given amounts of both reactants, so in this case we have 85.4 grams of chlorine, 34.6 grams of phosphorus, and you're given an amount of product, phosphorus trichloride, this time we're not told which one is limiting and which one is excess. We are given the amount of product actually produced. And so that's our actual yield. So if you look back at the previous problem, we're not going to use that until the very end. Okay, so we're going to put that on hold for a second and not worry about that 104 number. But the difference here is instead of telling you that one of them is excess and one of them is limiting, it's going to give you amounts of both reactants. So just like in your previous assignment, you have to take one of those 2 amounts of reactant, doesn't matter which one you start with, and convert it to grams of the other. So go ahead and let's just take the first one, 85.4 grams of chlorine, and convert that to grams of phosphorus needed. Let's go ahead and give that a shot now. Okay, so you can see there I got 24.87 grams of P4. That I labeled as needed. Whatever you calculate here in this step is the amount needed. So right now, again, we're just figuring out the limiting reactant. That's our first step. So which one's limiting? Well, if I have 34.6 grams of phosphorus, and maybe I should go up and label that. So this is how much I have. And I need less than that. Okay, about 10 grams less than that. That means that solid phosphorus is my excess reactant, right? So I'm going to label that somewhere. I'll just do it here in the problem. So I'm going to say ER, and that makes chlorine my LR. Okay, so I just found my limiting reactant is 85.4 grams of chlorine gas. So that's what I did first. So, and I should have labeled this. This is essentially step 1. Find your limiting, because step 2, and we didn't have to do that step in the previous problem, but we did have to do the next step, which is going to be to find your theoretical yield. But we always base our theoretical yield on the limiting reactant, the one that runs out. Okay, so that's going to be step 2. We're going to go from limiting reactant, in this case the 85.4 grams of chlorine gas, to theoretical yield, which, if we look at our actual yield, that's given to us as 104 grams of phosphorus trichloride. So we're going to find our theoretical yield, in this case, in grams of phosphorus trichloride. So see if you can go from your limiting reactant to grams of phosphorus trichloride right now. So there you go. I went from 85.4 grams of Cl2 because up above I decided that that was my limiting. And I took that to grams of PCl3. And I got 110.27 grams of PCl3. And I'm going to label that as my theoretical yield, because that's how much I should make if I fully react 85.4 grams of Cl2, which is my limiting reactant. If I would have done this calculation based on my excess reactant, 34.6 grams of phosphorus, I would have gotten a much bigger number, but that wouldn't be my true theoretical yield because I would be basing it on something that didn't fully react. So the last step then is going to find my, is the easiest really, and that's going to be to find my percent yield. So actual over theoretical. Actual, we're going to look back at the problem, 104 grams of PCl3. Theoretical is right there, 110.27. Again, I'm not going to worry about sig figs until the very end. And I should get 94.3%.